V not. Yep. This is grounded. This is your, I mean, op-amp in inverting configuration. Okay. You need to find the gain of this op-amp. Okay, you can take RF as 10 kilo and R1 as 1 kilo. What is gain? Yeah, minus 10. Right? What gain would be minus RF by R1, and that is minus 10 over 1. That is minus 10. Similarly, second one, right? For the same circuit, if your op-amp can source maximum of 15 amps current, right? Which your IMAX says 15 milliamps. Okay. You need to find the maximum current that the circuit can deliver to the next stage. Okay. Assuming the fact that it can source a maximum of 15 amps current. Yes, I should write that up, right? For the above. Okay. This is your question. Once you have part one where your RF issue is right. Second part, like this, that should be equal to 10 kilo. It's 1 kilo. Okay. What's the same ratio would be equal to say 100 kilo is to 10 kilo. Okay. And assume that maximum swing the four pan is from 0 to 10 volts. Okay. Was anyone saying something? Okay, this is your tag. Copy paste it. Fine. This is your diagram. Maximum swing of op-amp is 0 to 10 volts. Yeah, someone raised the hand. Go ahead and ask question. Amital, do you have any question? Okay, I assume it's my mistake. So how shall we proceed on this one? Anyone? See, op-amp can source maximum of 15 amps current, right? So your let's say I max that is equal to 15 milliamps, right? And your P, like at this node, and see, if I and it's I. Come again, I guess I'm not able to hear your voice. Yash, were you trying to say something? Okay, I guess I'll continue. Okay, so your see your IL max, right? Your IL max is your I max minus IF max. Do we have to find current for these three cases? Yes, we need to find IL max for these three cases. Your IL max would be I max minus IF max, right? And your IL max, right? That would be I max is 15 milliamp, right? 15 milliamp minus, okay, your IF max would be what? It's between these two nodes, right? So it would be This would be V naught by RF, right? Let's try to attempt as many problems as we can in this allotted time. So this is VO max by RF. Okay. Uh, yeah. So now if you do the math and uh, see gain we had already computed, right? We can compute this V naught as well, right? And uh, for RF equal to 1 kilo ohm, right? Your IL max would be equal to 5 milliamp, right? And for RF equal to 10 kilo ohm, example, right? Your this IL max would be equal to 14 milliamp, right? So RF equal to 100 kilo ohm, right? IL max would be how much? It would be 14.9 milliamp, correct? And now if you take the ratios, right? If your RF to R1 ratio is 1/10. Oh, I mean, sorry, this, right? Right. Option, I mean, the current values that you'll get. Uh, I mean, is this clear how I wrote this? Right. I mean, I use this equation. That's it. Okay. Thank you. Let's move ahead. Now coming to the next problem. So next one is that we need to find the transfer function. Okay, let's find the transfer function. This is your problem 3. Find transfer function. I guess for some reasons I'm not able to hear your voice. So just type in the chat, okay? Okay, find the transfer function for following circuit. Okay, so this is what VI. This is your R1. This is what VO. This is RF. And let's say we have capacitor in parallel. Right? Compute the transfer function of the circuit. I'll wait for the answer. I guess I'll start repeating myself. Now, the transfer function that be denoted by ZF of S. Okay, that would be your RF times 1 over SC. Okay, whole divided by RF plus 1 by SC. Okay, and that would effectively be your RF whole divided by 1 plus S times RF C. Correct? And if this is okay, this is VO of S, right? So now your final transfer function that would be your VOS by VIS, right? And that would effectively be what? Uh, I mean, this part was impedance, right? Of this, right? It was parallel capacitor and RF, right? So this would be yeah, minus ZF of S whole divided by, I mean, in frequency domain, your R1 would be R1, right? So the final answer that we'll get would be minus RF by R1 times uh, minus RF whole divided by R1 times 1 whole divided by 1 plus SRFC. Is this clear? So this would be the transfer function. And let's, I mean, if nobody has any question, then we can move on to the next question. Okay. So the next question is as follows. You have Q4. Right. Find the bandwidth, okay? Or I should say the pole frequency in hertz for the above circuit, right? If this is your circuit, I guess I'll copy it again so that okay, this is your circuit. And let's do one thing. Let's take all the set of RFS to R1 values that were provided in the above question, which question 2, right? Let's copy this as well. If I copy this, paste here, also assume that your C is 10 nano. Okay. Now, what would be the bandwidth, or I would say the pole frequency in hertz? Anyone? Now, first your bandwidth, right? That would be omega P1, or I would say that would be 1 over RF times C. Radians per second, obviously. The unit would be radians per second. Right. FP1, that would be 1 over 2 pi RFC hertz. Right. Your RF, I mean, for RF 1 kilo ohm, for RF 10 kilo ohm, and RF 100 kilo ohm, right? Uh, yeah, I guess I should simultaneously mention it as well, right? For RF 1 kilo, RF 10 kilo ohm, 100 kilo, I guess, yeah. The last one is 100 kilo. Right. Corresponding bandwidths would be, what would be bandwidth corresponding to this? Compute and let me know in the chat. It's simple, right? I need three bandwidth values corresponding to these three values of RF. For the first one, it would be 15.9 kilohertz, right? And add a factor of 10, or I should say divide a factor of 10, it would be 1.59 kilohertz. Likewise, for the last one, it would be 159 hertz, right? We're done. Question number 5. Consider a temperature transducer with following specifications. Right? You'll consider a. Was the question 4 clear? I have a doubt, so the bandwidth does not depend on components other than in feedback. I mean, yeah, the pole bandwidth would only depend upon RF and C. I mean, I guess this would already have been taught in your lectures, right? Also, I mean, I'm not able to hear your voice if anyone was speaking uh, while I was solving problems. Pardon me for that. I mean, you can type in the chat because for some reasons the speaker voice isn't coming up. Okay, I shall proceed now. Now, temperature transducer. Okay. Now, your temperature transducer would have, suppose that we have following specifications. Your sensitivity, right? Your sensitivity is 10 millivolts per degree Celsius, right? Voltage at 0 degree Celsius, right? Voltage at 0 degree Celsius. That would be, say, 0 volt. Okay, output impedance. That is RS. Okay, with these specifications, suppose your temperature transducer is modeled as, suppose it's modeled. Okay, let TT stand for temperature transducer. Okay, suppose it is modeled as a variable voltage source. And where your Vs would vary with temperature at, I mean, Vs varies with T uh, at 10 millivolt per degree Celsius. Okay, this is how your Vs varies with temperature. So now if the circuit in this question, okay, suppose I take this particular circuit. Okay, and uh, suppose that this circuit is used to process the signal from the temperature. Okay, suppose your input is temperature and you get what's the signal. Okay. Now, so what would be your input? Your input would be a temperature transducer, VS, right? Let me make the diagram. That way it would be clear. So this we have following. This is my what? Temperature transducer that is modeled as a variable voltage source. Okay, VS. And suppose that VS is, I would say, 10 millivolts per degree Celsius. Right. At 0 degree Celsius, VS is equal to 0 watt. This is RS. Okay. VI. This is R1. Yeah, rest of the things are fine. Oh, I guess I should attach a capacitor as well. This be C. Okay, C, RF, PO. Rest of the things are fine. R1. This is also fine. VI, RS. Yeah, rest of the things are fine. Okay. Uh, you need to find the value of the RS. Okay, find this value for which, yeah, please. Someone was saying something, right? Okay, feel free to type that in chat. I was not able to do that. Okay, now you need to find the value of the RS for which your DC gain of the circuit is maximized. Yeah. What is your DC gain of the circuit? DC gain of the circuit would be VO by VS. Right? The output by VS. I mean, ratio of these two. Right? Yeah. Anyone? I guess someone has forgot to mute. Let me mute that. Who is unmuted? Why am I not able to? How to find RS? Yeah, wait, I mean, I'm coming to that. So I hope you understood the question. I mean, that is what we need to find out, right? We need to find out the value of the RS for which your DC gain of the circuit is maximized. First of all, what is DC gain of this circuit? I mean, don't get confused. Yeah, PO by VS. I mean, there was formula in terms of impedances and resistances, right? So it would somewhat be minus times this impedance divided by sum of these two. Does everyone agree? Has to be like that, right? Now, when will the gain be maximized? When this would be minimized, right? Because this is occurring in denominator. And when you make it zero, that would effectively be the point where gain is maximized because at that time, RS plus R1 would be R1, right? So the answer that I'll write is RS equal to zero, your gain is maximum, right? I mean, absolute gain. Now, coming to the next question, sixth one, right? Now, for this circuit, suppose your RS is 100 ohm. Okay, use RS 100 ohm and find the magnitude of the DC gain, VO by VS. I mean, you need to find the magnitude of the DC gain for all the set of RFS to R1 values that it provided in the question. I guess I'll copy them again. Right, I'm talking about these. Where was the ratio? Yeah, in this. Okay, the question is, I hope you got it. We concluded that the gain would be maximum for RS equal to 0. Now let's take RS as what? 100 ohm. Now find the magnitude of the DC gain. Is the question clear? In fact, for question 2, there was no capacitor, right? Precision. I don't need this. RF. Okay. 1 kilo is to 100. 10 kilo is to 1 kilo. 100 kilo is to 10 kilo. What would be gain for this one, for this one, and for this one? Yeah, it would be 5 for this one. Similarly, what about next? It would be 9.09 for this one. Can you zoom out? Oh, sorry. Zoomed out. Right, for second one, where your RF is to R1 is 10 to 1, right? And your RS is 100 ohm. It turns out the gain would be 9.09. Likewise, for the last case, the gain would be 9.9. Okay, these, I mean, this finishes your question 6. Now, what about seventh? Yeah, 9.09. Likewise, for the last one, it would be 9.9 as I wrote. Now, for question number 7, let's do one thing. Uh, Let me take this question. I mean, take this circuit again. Okay. right? Suppose your V is that is equal to 10 millivolt per degree Celsius. Okay. Yeah, at 0 degrees Celsius, your Vs is equal to 0, right? Now the question is, um, you need to find the value of the RS. What would be the value of the RS for which your gain of the circuit is maximized? I mean, firstly, if you would have a look at this, this is cascaded connection, right? So your gain would be maximized. Which configuration is this? Will value of RS matter? I mean, we have two, I would say, uh, remember last time we did let this have gain E2, let this have gain E1. What about this? Will gain depend on RS for this? Yeah, somebody mentioned this is voltage follower, right? So the gain won't depend upon RS, right? So since the question was to find the value of the RS for which your DC gain of the circuit would be maximum, I'll answer that as your gain is independent of RS. Is this clear? Done. Now, question number 8. Find the gain of the circuit shown below. Assume R1 equal to R3 equal to 1 kilo ohm. Okay. And your R2 and R4, they both are equal to 10 kilo ohm. Okay. Now, what would be the gain of this circuit? Okay, I don't have that screen share, so I need to. Okay, this is what I'm talking about. Because this is VI. Okay, this is R1. This is R3. Mine's plus. Let this be R4. This be R2. Let me give the, let me give you the values, okay? Here, R1 is R3, that is 1 kilo ohm. Your R2, R4, that is 10 kilo ohm. Okay, so what would be the gain of this circuit? Is the gain, okay, let me write it up. I mean, you can compute this for yourself using analysis. Your V output would be minus R4 by R1 times Vi plus your 1 plus R4 by R1 R2 upon R3 upon plus R2. Right? I mean, you can follow the same procedure as you had taken up in order to, I mean, arrive at the expression of the gain for one of the two configurations of the op-amp. You can use same principles here, and you'll obtain the expression of the output, right? Now, in our case, R1 and R3 are same, right? And also your R2 and R4 are same, right? R1 and R3 are same, R2 and R4 are same. So, I mean, I can write following. Your V output would be equal to minus R4 by R1 times Vi plus R1 plus R4 all divided by R1, R4 all divided by R1 plus R4. Right, I am just using this fact, this and this. This times Vi. Right, if you use this, following is the VO, I mean V output that you will get. You'll get V output as minus R4 by R1 times Vi plus your R1 plus R4 by R1, right? Uh, I mean, R1 and R4 are simplify this, you'll arrive at following, right? It would be R4 by R1 times Vi, right? Your common mode gain would be 0, right? This would imply, I mean, this implies if R1 equal to R3 and R2 equal to R4. Okay, so this finishes your eighth, right? Your eighth is done. Ninth question. Question number 9 is following. The value of the resistor R3. Suppose I take up the same circuit. I mean, I'll draw it again. Suppose that this is your circuit, okay? Uh, Now, if I plug in the values, just a second. If you change R3 to 900 ohm, okay? Suppose now R3 is 900 ohm, okay? But R1 is still 1 kilo ohms. Now R3 was changed to 900 ohm, right? All the other resistors uh, having the same value. Uh, what would be your gain of the circuit? Share the session PDF. Yeah, I mean, I'll share this PDF. Uh, what about this though? I mean, try to find the gain. Your gain is V output by V input, right? And that is how much? I mean, if you will plug values in this particular equation, your gain, V output by V input, that is 91.7 milli. Yeah, 0.0917, correct. And that is, right, question number 9 is done. What about 10? For 10, you need to find the output voltage for the circuit. The following is the circuit. Try to make it. Okay. Try to find the output voltage for this circuit. I'll give you the values. Okay. Here. Uh, R1 is 200 ohm. R2 is 600 ohm. Here R3 is uh just a second. R3 is R4 and that is 1 kilo ohm. Okay. VICM is 2 volt. Here VI that is 2.5 into 10 to the power times 3 sine of omega t. I mean, these many volts. Okay, VI is this much. Yeah, what would be the V out? VO? You're saying 0 volt. Why? Why would it be 0 volt? It won't. I'll tell you the answer, which you'll try to um, verify at your own end. It turns out that your V output is 35 into 10 to the power minus 3 sine of omega t. Okay. And what is, I mean, while computing the transfer function, we'll obtain following. Your V output by V input, that is 2 times R4 by R3. 1 plus R2 by R1 by R2. Right? No, this is 2. R1, R2, R3, R4 times. Yeah. So since you'll use this particular VI, right? You'll use this V particular VI. This is what V output you'll get. This expression would be, I'm leaving it as an assignment for you to find how this V output by VI is this much. Okay, so that would effectively be, I mean, that is in fact your output voltage for this circuit, right? VO. After that, does anyone have any question regarding these 10 questions that we did so far? Please explain the 10th question. I mean, this is what I left for you, right? Values of R1 R2, R3, R4, that where these resistor values, they are provided, right? They're given. Okay, VICM, you know, okay, so this is 2 volt here, right? Now, V input is this much, right? How would you find VO by VI for this one? When a question comes to find bandwidth, it generally means pole bandwidth. I mean, it would be provided. For the question that we did, it was pole bandwidth, in fact. Any other question? Okay. Were you able to access the previous session's recording? Question 10 is perfect answer. Yes, and can you explain here how you approached for that? Oh, no, no, no. I mean, I want everyone to attempt it. You can mail me, okay? Mail me how it came about, the answer, okay? I mean, the hint I would give you is the circuit is designed so that these common mode cancels out, right? While your differential gets amplified, right? Differential input gets amplified. In fact, compute the gain of the first stage, that is the two left op amps first, right? Uh, and then compute the gain of the second stage, that is your right op amp. Okay, and yeah, that's how we'll proceed. Can you suggest some source to find NPTEL level exam? But by help of your equation, I'll do it half. I did not get what you are trying to say. Do one thing, you can mail me, okay? Just mail me and I'll entertain it accordingly. Any other question? Please make sure to attempt this 10th question. And I mean, I already gave you the expression V output by input, right? I need a detailed analysis on how you arrive at this V output by input. Is that clear? I mean, then I'll do one thing. I mean, either I would share the best solution with everyone, and or I will do one thing if no one is able to send me the solution. Uh, let's keep 2 days as the time. If no one is able to send me the solution within 2 days, I'll send one solution from my side, everyone. Only to those who attempted it. Okay, so make sure and mail it. Or otherwise, if you are sure you got the answer, you can keep it to yourself. Okay, if no one has stopped, okay, I'll be stopping the recording. Please share my contact. I mean, I had already shared it, right? This is my contact. This is the email ID that you can. Okay, I guess probably screen is. Okay, this is email. And yeah, this is the YouTube channel one. Just okay. Second one is my YouTube handle, and the first one is the email ID. I'll be stopping the recording now.